Hello and welcome to our Mole Map podcast. We are going to go over how to use your mole map so that you can find your way from point A to point D in your mole conversions. All right, this is your mole map. For you visual learners, this is a good way to think about how we can convert between units using our middleman, the mole. Notice that the mole is in the middle of these. For you students who are more mathematically inclined, this is probably going to make your head hurt a little bit. If you're more mathematically inclined, you may want to stick to creating your T-chart and converting from one unit to the next and using your unit map. However, I think this is a nice tool for learning about the mole and all the conversions we can do using the mole. All right, let's just take a look at what we have here. So we have these units surrounding the mole. So we can convert from grams to moles using the molar mass. Okay, so our previous podcast talked about what the molar mass is, and that's moles per gram of a substance or grams per mole of a substance. So if we are wanting to go from moles to grams, this is a conversion factor I use where I put that numerical value with grams over a mole for that substance. If I want to go the opposite way, guess what I do? I'm going to flip that conversion factor over. So I have a two-way path. Same conversion factor, it's just a matter of what's on top and what's on bottom in order to cancel units and wind up with a unit you're looking for. We can also convert gas to moles. So if we are talking about a substance in terms of liters, we know that 1 mole of a substance or 1 mole of a gas is equivalent to 22.4 liters. So we can use that conversion factor to either go to moles as a unit or go to liters. If we're trying to measure volume. We can also describe molarity and moles, so we can do moles per liter to calculate the concentration, or we can use molarity times liters to tell us how many moles are in a particular substance at a particular concentration. We have talked also about using Avogadro's number to know that there is 6.02 times 10 to the 23 atoms or molecules in a mole. So depending on whether we're converting our substance to moles or we're converting our substance to atoms and molecules, and I'm just going to put atoms and molecules here because those would be your keywords, we have conversion factors for that. All right, so I don't recommend probably memorizing this unless you find this to be an incredibly helpful tool. What I would do is I would probably work with this image as you're doing your conversions. Keep in mind, let's say I want to go from matter, so from atoms to grams, there's not a direct route. So to go from, and I'm just going to clean this up real quick, if I want to go from atoms to grams, I'm going to have to go to the mole and then to grams. So that's a two-step conversion. If I want to go from grams of something to concentration or molarity, I have to go through the mole first. I have to convert grams to moles using the molar mass, and then I can convert to molarity. So in the last slide, I somewhat described how to use the mole map. Let's put that into words as a process. So we always determine what you're starting with. What are you given in your problem? Is it grams? Okay, great. Then you're starting up here with the molar mass. Determine what you're ending with. Are you trying to find atoms? If so, you want to end up down here in Avogadro's number with matter. Okay, so where am I starting? Where am I going? And if we use this example that I just gave you, we would also need to determine what ratios to get to the end. So let's just say I have grams and I do my unit map and they want me to go to atoms of a substance. There is no direct route, so instead I'll have to go from grams to moles and then moles to atoms. So on this path, you'll notice that I'll have to use this conversion factor first, and that's going to be 1 mole of a substance over the grams of the substance to cancel out grams. Once I'm at the mole, I'm going to follow the correct arrow to get to matter, and I'm going to use, apologize, I'm trying to color code these. I'm going to have to use this conversion factor, 6.02 times 10 to the 23rd on top, that's atoms, over 1 mole. Notice that moles will then cancel, leaving me with the unit I'm trying to find. So you can use this as a tool to figure out your conversion factors. If math comes naturally to you or the T-chart is working for you, all you gotta do is make sure that your unit on the bottom cancels the previous unit in the T-chart. Let's work a sample problem together. This question asks me how many molecules, so I'm looking for molecules, are in 4.0 moles of carbon dioxide. So I am starting with 4.0 moles of carbon dioxide, and they want me to go to molecules of carbon dioxide. So I'm going to go ahead and put my pen, I'm going to put a little asterisk here in the mole bubble. I'm starting in moles, and because it's molecules, and we've said before, matter in Avogadro's number describes atoms and molecules. Be careful how you abbreviate that. You don't want it to look like moles. I know that I'm going to go from moles to matter. So I'm going to use this conversion factor. I say one-step conversion factor since we're starting in moles. And my conversion factor, I'm going to extend this arrow so that I can show you, is 6.02 times 10 to the 23rd over 1 mole. Notice that moles will cancel. So I've just essentially done the entire problem just by drawing my unit map. But let's formally put it into a T-chart. So 4.0 moles, and I'm going to abbreviate moles. I saved myself so much time doing that. And I'm going to put in this conversion factor next, 6.02 times 10 to the 23rd. Now, one thing to be careful of on your T-charts is to make sure that you are always putting number, unit, substance, number, unit, substance. Initially, as we're working through these problems, your substance isn't going to change. Later on, when we get into stoic, which is coming real quick, our substance will change. So it's going to be helpful to have all of those pieces of information in every box so that you can track the changes that are happening. So we have 6.02 molecules, because this is a compound, of CO2 per 1, and I don't usually write 1 because I don't want to confuse myself with sig fig rules, per 1 mole of CO2. Okay, moles of CO2 will cancel, leaving us with molecules, which is good because that's what I'm looking for. We multiply across the top, then we divide by the bottom. And since this is the only value given in the problem and it has 2 sig figs, I'm going to report my answer to 2 sig figs as well. So we're treating all of the conversion factors in the mole map as exact numbers and the values given in the problem as inexact numbers. So multiplying across the top, dividing by the bottom, you should get 2.4 times 10 to the 24th molecules. I can't even write molecules. Molecules of CO2. One thing to keep in mind is when we do wind up in that matter bubble by Avogadro's number, you're going to wind up with an incredibly large number. So having an exponent there makes perfect sense. If you're feeling confident on this, by all means, do this problem on your own. You can pause me and check in for the correct answer. And if you didn't get the correct answer, go back and watch it. All right, this question asks us how many moles, so I'm looking for moles, are in 3.0 times 10 to the 23rd atoms of gold. So I'm starting, remember that Avogadro's number is atoms or molecules. I'm starting here, and I should be ending at moles. Well, that's the conversion factor I'm going to use to go from atoms to moles. So let's first just do our unit map, because that's a good habit to be in, especially before we get into stoichiometry. I am starting in atoms of gold, and I am going to go to moles of gold. The conversion factor, according to my mole map, is I'm going to have 1 mole of gold per 6.02 times 10 to the 23rd atoms of gold. So again, I've pretty much set up my problem for myself here. I'm going to go ahead and plug in actual numbers into a T-chart. I have 3.0 times 10 to the 23rd atoms of gold, AU. And my conversion factor, I want to cancel. This isn't atoms. I want to cancel atoms. So that's going to have to be on the bottom. 6.02 times 10 to the 23rd atoms of gold. And that is per mole of gold. Double checking, that's what I'm looking for. So I am ready to multiply across the top. So 3.0 times 10 to the 23rd times 1 divided by 6.02 times 10 to the 23rd. Quick pro tip. You are going to want to enter this into your calculator like this. You're going to use the big E button. Okay, big E is the same thing. This E is equal to saying times 10 to the. So you don't have to put in times 10 and the little caret. That's going to save you potentially some button pushing errors later on. So your E takes the place of that. And then we just put in our exponent. And then you'll say, we don't say times 1 because that's just useless. And then we're going to divide by, and I'm going to use parentheses again. If I don't use parentheses, it's going to take 3.0 times 10 to the 23rd, and it's going to divide the exponent, 23, by the rest of the numbers. So I would over parenthesize if I were you, just to be on the safe side. So again, we're going to put this in with an E, 23. When you multiply across the top and divide by the bottom, and again, looking at this, 2 sig figs in our answer, we're going to round to 2 sig figs, we get 0.5, and we are going to add that additional 0 on there to make that significant so that we have 2 sig figs. Our unit is moles, our substance is gold. So number, unit, substance. Same approach as we've been doing. Again, if you're feeling confident, do it alone without me. Check in on the right answer. They want us to determine the mass, and mass is in grams. That's what we're trying to find, in 2.56 times 10 to the 25th molecules of sodium sulfide, which they tell me is Na2S. All right, fantastic. It's important, and you'll see that this is going to come back to haunt us. If you cannot convert a name to a formula or a formula to a name, that's going to be really difficult for you to calculate the correct molar mass, and then you won't be able to use the correct molar mass in your mole conversions, and it's going to make life so difficult. So if that's something that you struggled with, please, please, please go back and review those older podcasts. Okay, let's look at our mole map and figure out where we're starting and where we're going. So we're starting with molecules. Remember, molecules is matter. Okay, so we're starting here and we are ending, they want us to find grams. Well, there is no direct unit or path from molecules to grams. I'm going to have to go through my middleman, the mole, and looking at the direction of my arrows, I'm going to use this conversion factor. And then I'm also going to use this conversion factor that's next to the green arrow. Okay, so because I have to convert to moles first, and I'm going to draw this out on a unit map, I'm starting in molecules. I will then go to moles. I will then go to grams. Okay, my first conversion factor from molecules to moles is using Avogadro's number. So I'll put 1 mole on top, 6.02 times 10 to the 23rd molecules on the bottom. My second conversion factor to go from moles to grams is the molar mass, and I'm going to put MM for molar mass. This is also the grams per mole. Grams per mole is how we're going to get from moles to grams. We'll cancel out moles that way. So we've pretty much set up this problem. The one thing I haven't done that I'm going to need to do is to add up my molar mass. I want to have that number ready before I start to get to my T-chart. So I have 2 sodium, so that's 2 times 22.99, that's off the periodic table, and I'm going to add that to 1 sulfur. 1 sulfur, looking at my periodic table, is 32.07, 32.07. Okay, so 2 times 22.99 plus 32.07 is going to give me 78.05. And I'm maintaining 2 decimals for this, grams per mole. It's a molar mass, so it's a ratio. All right, let's go ahead and set up our T-chart. Boom. 2 0.56 times 10 to the 25th molecules. Again, I'm going to make sure I put that C at least on there of my sodium sulfide. Don't want to abbreviate to MOL. I don't know if you're talking about moles or molecules. First conversion factors right here. 1 mole of sodium sulfide is equivalent to 6.02 times 10 to the 23rd molecules of sodium sulfide. This is tedious right now to have to write all this out. I assure you it's going to be worth it in the end on the next podcast. All right, finally, we are in moles. We're going to use that molar mass. So I'm going to put moles of sodium sulfide on the bottom because I want to cancel moles like I canceled molecules. And I'm going to put the molar mass that I calculated, 78.05 grams per mole. Multiply across the top, multiply across the bottom, divide the top by the bottom. Do not round until the very end. We are going to round this to 3 sig figs. Okay, we have 3 sig figs here that are given. We would typically look to our molar mass to include that as well. That's a measured amount. It's an inexact number. But in this case, there's 4 sig figs. That's not less than 3. So the answer will have 3 sig figs. So I will round. It should be 3,320 grams of sodium sulfide.